Hello guys, welcome to our channel. So today we are going to continue with our A-level integration revision series. So these are questions of November 2023 question papers, and in this tutorial we are going to review key techniques for solving integrals covering basics, definite and indefinite integration. Okay, so here we are having this question number 9 of our series, which says the variables x and y satisfies the differential equation x squared dy by dx plus y squared plus y is equal to 0. So it is also given that x is equal to 1 when y is equal to 1. So we are required to solve the differential equation to obtain an expression for y in terms of x. So here we are given this differential equation x squared dy by dx plus y squared plus y being equal to 0. So the first step here is to shift y squared plus y to the other side of the equation, and on the left hand side of the equation we are going to be left with x squared dy by dx. So it is now x squared dy by dx being equal to negative y squared plus y. Okay, so let us divide both sides by x squared. So on the left hand side of the equation we are going to be left with dy by dx being equal to negative y squared plus y over x squared. So if we multiply both sides by dx, it is now dy being equal to negative y squared plus y multiplied by 1 over x squared dx. Okay, so here let us divide both sides by y squared plus y. So it is now 1 over y squared plus y dy is equal to negative 1 over x squared dx. So here we can integrate both sides to say it is now the integral of 1 over y squared plus y with respect to y, and the integral of negative 1 over x squared with respect to x. So here on the left hand side, to integrate this function, the first thing we need to do is to express 1 over y squared plus y in partial fraction. So we can now say taking 1 over y squared plus y. So it is now 1 over y squared. So on the denominator we can factor out y. So it is now 1 over y multiplied by y plus 1, which is equal to a over y plus b over y plus 1. So if we multiply both sides by, if we multiply every term by y multiplied by y plus 1, we are going to get 1 being equal to a multiplied by y plus 1 plus b multiplied by y. So here we can let y be 0. So if we let y be 0, this b becomes 0. So we are going to be left with 1 being equal to a. So a is equal to 1, and we can also let y be 1. So if y is equal to 1, this gives us 1 being equal to 2a plus b. So is equal to b is equal to 1 minus 2a. A is equal to 1, so it is 1 minus 2, which is equal to negative 1. So b is equal to negative 1. Therefore 1 over y squared, 1 over y squared plus y in partial fraction is equal to 1 over y minus 1 over y plus 1. So here we can rub this, okay. So we can now say this is the integral of 1 over y minus 1 over y plus 1 with respect to y being equal to negative of the integral of x squared can be expressed as x raised to the power negative 2 with respect to x. So to integrate 1 over y, we are going to use our law of recognition. So here we are going to integrate using the recognition method. So the recognition method states that if we are integrating an expression of this form, f prime of x over f of x, our answer with respect to x, our answer will be ln f of x. So this only works if the numerator is a complete derivative of the denominator. So if we are having 1 over y, our derivative of the denominator is 1. So this gives us ln y. So the integral of 1 over y is simply ln y. And also the integral of 1 over y plus 1 is simply equal to ln y plus 1, because the derivative of y plus 1 it is equal to 1. Okay, so here we can now say the integral of these expressions on the left hand side of the equation, it is ln y minus ln of y plus 1 being equal to negative 1 over negative 1 multiplied by x raised to the power negative 1 plus c. Okay, so it is now ln y minus ln of y plus 1 being equal to x raised to the power negative 1 plus c. So we are given that when x is equal to 1, y is also equal to 1. So here we can substitute the values of x being equal to 1 and y being equal to 1. So it is now ln 1 minus ln 2 being equal to 1 raised to the power negative 1 plus c. So ln 1 is equal to 0, and here we are going to be left with negative ln 2 being equal to 1 plus c. So c is equal to negative 1 minus ln 2. So this is the value of c. So we can now say ln y minus ln of y plus 1 being equal to 1 over x minus 1 minus ln 2. And we are being asked to find an expression for y in terms of x. So we need to make y the subject. So here we can combine these two logarithm functions on the left hand side of the equation using our law of logarithms, which says if we are having ln a minus ln b, for example, this will gives us ln a over b. So we are going to use this idea to combine these two logarithm functions on the left hand side. So we are now having ln of y over y plus 1 being equal to 1 over x minus 1 minus ln 2. So for us to get rid of this ln, we are going to apply exponential both sides. So it is now e to the power ln of y over y plus 1 being equal to e to the power of 1 over x minus 1 minus ln 2. So exponential and natural logarithms, these two are inverse of each other. So on the left hand side of the equation, we are going to be left with y over y plus 1 being equal to e to the power 1 over x minus 1 minus ln 2. So if we multiply both sides by y plus 1, we are going to get y being equal to y e to the power 1 over x minus 1 minus ln 2 plus e to the power 1 over x minus 1 minus ln 2. So here we can also shift this term here, y multiplied by e to the power 1 over x minus 1 minus ln 2 to the left hand side of the equation. So it is now y minus y multiplied by e raised to the power 1 over x minus 1 minus ln 2 being equal to e raised to the power 1 over x minus 1. So it is minus 1 minus ln 2. So here we can factor out y. So it is now y 1 minus e to the power 1 over x minus 1 minus ln 2 being equal to e raised to the power 1 over x minus 1 minus ln 2. So y is equal to e to the power 1 over x minus 1 minus ln 2 over 1 minus e raised to the power 1 over x minus 1 minus ln 2. So this is our final answer.